Okay, for 12 part A, we're going to expand these brackets and hopefully show that, I think that's meant to be equal to 1 plus sine 6 theta. So multiplying out the brackets. Same bracket twice. Is going to be sine squared 3 theta plus a sine 3 theta cos 3 theta and then another one. So 2 sine 3 theta cos 3 theta plus cos squared 3 theta. Notice here we've got a sine squared theta or sine squared 3 theta plus cos squared 3 theta. That's equal to 1. So we've got 1 plus 2 sine 3 theta cos 3 theta. Now, we know that sine 2x is the same as 2 sine x cos x. We've got a 3x or a 3 theta here. So what's that going to be equal to? Oops, cos 3 theta. Well, whatever I have here, I'm going to have twice as many here. So 2 sine 3 theta cos 3 theta must equal sine 6 theta. So that is equal to sine 6 theta, which is exactly what they've got up at the top there. Okay, for part B, it says use the result and for the range of 0 to pi over 2, solve this equation. So sine 3 theta plus cos 3 theta equal to the root of 2 plus root 2 over 2. We've got that sine 3 theta plus cos 3 theta squared is equal to this. So this is the square root of that. So we've got the square root of 1 plus sine 6 theta needing to equal 2 plus root 2 over 2. We can obviously get rid of the roots. We can square both sides. I'm not really sure why they put them in there in the first place. So this is the problem that we have to solve. I'm going to subtract 1 to get the sine 6 theta on its own. So 2 plus root 2 over 2, take away 2 over 2, so that I can bring it together, which is going to be 2 plus root 2, take 2 over 2. 2's on the top are going to cancel, so we're going to have just root 2 over 2. So if we inverse sine that, we will get what 6 theta equals. So that's pi over 4. Notice that this is 6 theta, which means we have to extend the range that we were given by 6 lots. There's going to be 6 times as many answers in this than there would be if it had just been theta. So the range we were given was 0 to pi over 2. So that's just 90. So we need to do 6 of those. That's going to be 3 parts of the sine graph. So we're going to have to go, there's pi there, 2 pi. We're going to have to go up to 3 pi. So there should be 4 answers that we're looking for. So here's our root 2 over 2. First one we've already found, that's pi over 4. This next one is going to be pi minus pi over 4. So that's going to be 3 pi over 4. Next one is going to be 2 pi plus pi over 4, which is 9 pi over 4. And the next one's going to be 3 pi minus pi over 4. Which is 11 pi over 4. Now we need to divide every single one of those by 6. So that's going to be over 24. I'll cancel these down in a minute. These middle two cancel down. So pi over 24. 3 over 24 is the same as 1 over 8. So we've got pi over 8. 9 over 24 divides by 3 top and bottom. So that's going to be 3 over 8. So 3 pi over 8. And the last one doesn't cancel. 11 pi over 24. So the last thing we need to check is if all of these values are valid. And earlier I said I don't know why they did this rather than what we've got here. We need to check that this is still valid for the question that they've given us. So the last thing to do is check that when we substitute the values that we've got in, that we do actually get the positive square root of 2 root 2 over 2. Because we squared both sides, and that can lead to extra solutions that you don't want. So we're just going to now check for each of these values that sine 3 theta plus cos 3 theta does give us positive root 2 plus root 2 over 2. So I'm going to just type each value in. So we need the answer to be the root of 2 plus root 2 over 2. And if you work that value out, that's 1.307. So I'm just going to check that for each of these values I am getting 1.307. Okay, I am not getting it for this one. So that's not actually a valid solution. I'm getting negative 1.307. Same for the last one. That's not a valid solution either. And it's because of the cos 3 theta. We changed it into 1 plus 6 sine theta, which was fine, but we then squared both sides. So even though because when you square negative 1.307, we do get 2 plus root 2 over 2. But that wasn't actually the question we were solving. So we need to make sure that we get the positive version, not the negative version. So that's just these two answers here.